Hello and welcome to Mathematics with Simon. I'm Simon, Chewy's rounding about. One of our French viewers has asked us to look into Zeno's paradox, or one of Zeno's paradoxes. It's to do with a race between a sausage dog and a tortoise, and they race over 1 kilometre. I think the original might have mentioned Achilles and the tortoise, but we've customised it. The dog is twice as quick as the tortoise. The tortoise is given a head start of 100 metres. So the question is, what happens in this race? Well, our instinct might be that the dog might win because the head start isn't that big and the dog is twice as fast. But this is how Zeno reasoned. He said, well, when Chewy gets to 100 metres where the tortoise started, the tortoise is gone. He's at 150. He's travelled 50 because he's only half as fast, so in the time it takes Chewy to travel 100, the tortoise has travelled 50. When Chewy gets to 150, again the tortoise is up ahead. He's at 175 because he's travelled 25 in the time it took Chewy to travel 50. And when Chewy gets to 175, you've guessed it, the tortoise is ahead again. So on that basis, the tortoise is always in front, and so in the end, it wins. That might be the reasoning. Now, why is this a paradox? Because it seems to use sound reasoning but does not get to the answer we would expect. Surely Chewy should win. For instance, if he runs at 5 metres per second, which means he'd run 100 metres in 20 seconds, so he's running not that quickly, right? I mean, the human world record's like under 10. He finishes in 200 seconds, 5 metres per second, so you go time equals distance divided by speed. So time, 200 seconds, equals distance, 1,000 metres divided by speed, 5 metres per second. 1,000 divided by 5 is 200. The tortoise will travel at 2.5 metres per second. It's travelling 900 metres because it's got a 100 metre head start. And as we all know, 900 divided by 2.5 is 360 seconds. Just to check that, 360 times 2 is 720, then half of 360 is 180, 720 plus 180 is indeed 900, so it does actually work. So the tortoise is a lot slower. Chewy should win by 160 seconds. So what's going on? Well, the first place to start is here. Actually, a half plus a quarter, plus an eighth, plus a 16th, plus a 32nd, plus ... plus a 64th, plus 128, ... Add them all up, that equals just 1. It doesn't go on forever. It doesn't equal infinity. So to put it another way, the distances we've talked about, 100 metres, plus 50 metres, plus 25 metres, plus 12.5 metres, add them up, ... that actually only comes to 200 metres. You can sort of tell with the first series, because if you add a half plus a quarter, there's only a quarter left to get to 1. Then you add an eighth, there's only an eighth left to get to 1. Then if you add a 16th, there's a 16th less. So each time we're adding something on, it's halving the distance left to get to 1. So if we keep going forever, the distance tends towards 0 and you end up at 1. In the same way, by adding these 100 plus 50 plus 25 plus 12.5, you're always halving the distance that's left to 200 metres. The second bullet is like the first bullet, but it's all times by 200 metres. So the point is, this analysis actually only works up to 200 metres. So actually, in the end, Chewy wins. And since Chewy wins, he's going to get a nice little reward. Come on, Chewy. Chewy, you want this? Come on. It's the star of the show, and he gets this chicken. You like that, mister? Good lad. So, he wins. The point is, so the analysis worked for an infinite number of iterations, but not an infinite distance. It only covered the 200 metres that Chewy covered, or the 100 metres that the tortoise covered, or it only covered the first 40 seconds. So it works for an infinite number of iterations, but not an infinite distance and not an infinite time. It just covered 40 seconds. although it felt like it should work infinitely, that only applied to iterations. And actually, we could have smelled a rat right at the beginning, or indeed a rat dog, because now he's had his food, he's off. Because basically, the argument that the tortoise stays in front, actually, that argument would have worked for any distance, any speed, as long as the tortoise was slower than the dog, or any head start. So this kind of argument is too strong to be true. It can't be the case that the animal that starts in front will always win for any speeds, any head starts, any distance. So it must have been a false argument. We really hope you've enjoyed this. If you have, please hit like, and you're very welcome to subscribe and hit the notification bell. We'd love to hear more ideas. We very much hope you enjoy your mathematics, and we look forward to seeing you soon.